Good morning, student. So far in this course, we have discussed superposition of two different harmonic oscillation. First one is superposition of two HSM, simple harmonic motion, with similar frequency, and then we discussed also superposition of two SHM with different frequency. Okay, today we are going to discuss superposition of two simple harmonic motion of same frequency, but they are traveling in perpendicular to each other. So today topic is superposition of two SHM perpendicular to each other, having same frequency. Okay, this will be today's topic. So let's consider two simple harmonic motion. X is equal to a1 cos omega naught into t. Okay, so other frequency should other simple harmonic motion should be in a direction perpendicular to x direction. So let's take, this is y is perpendicular to the x-axis, so we can take y is equal to a2 cos omega naught into t plus phi. Okay, so amplitude of first simple harmonic motion is a1 and its frequency is omega naught. The amplitude of second SHM is a2 and its frequency is also omega naught, and having a phase difference phi with respect to the first simple harmonic motion. Okay, and they are moving perpendicular to each other. So now what we have to do, we have to find out the resultant of the two waves. Okay, if two simple harmonic motion, if they superimpose, then we have to find out what will be the resultant simple harmonic motion, what type of simple harmonic motion they will result. Okay, so let's say this is equation 1 and this is equation 2. This is a very important derivation. From here you can actually understand what is elliptical polarization, what is circular polarization, what is plane polarization. Every polarized light is basically consists of superposition of two waves which are actually perpendicular to each other. Okay, and having different phase differences. So you will see at the end of the derivation. Okay, so first let's see the second expression, y is equal to a2 cos omega naught plus phi. Okay, from here we can write y divided by a2 is equal to cos omega naught t plus phi. Okay, so we can write y divided by at cos omega naught into t into cos phi minus sine omega naught into t into sine phi. Okay, this thing we can write. But as you can see from equation 1, cos omega naught t a1 is equal to x1. Therefore, in this place we can write x divided by a1. Okay, and similarly in place of sine omega naught into t, we can write root over 1 minus cos square omega naught into t. Therefore, what we can write 1 minus x square divided by a square. Okay, so we'll make this substitution in this equation, and finally we will get y divided by a2 is equal to x divided by a1 into cos phi minus root 1 minus x square divided by a square sine phi. This expression we will get. Okay. Okay, so I will just rearrange the term here. What we will get, x divided by a1 cos phi, this thing, minus y divided by a2 is equal to what I will write. I have taken this quantity this side, so this quantity will come to this side. So what we will get, 1 minus x square divided by a square into sine phi. So this is the equation 3. Okay, so now what I am going to do, I am going to taking the square of this equation 3 and see what kind of condition or trajectory this equation will follow. Okay, so let's square this equation 3. So if we square the equation, then what we will get, x square divided by a1 square. First term will be like this. Then we will get cos square phi. Okay, then we'll get plus y square divided by a2 square. Then we'll get 2xy a1 a2 into cos phi is equal to the right hand side we will get 1 minus x square divided by a square into sine square phi. Okay, this thing we will get. So now I can take out this part, minus x square a square sine square phi in this in the left hand side of the equation, and finally we will get x square divided by a1 square, then cos square phi plus sine square phi. Okay, plus y square divided by a2 square minus 2xy a1 a2 cos phi is equal to sine square phi. Okay, cos square phi plus sine square phi is equal to 1. Therefore, x square divided by a1 square plus y square divided by a2 square minus 2xy divided by a1 a2 cos phi is equal to sine square phi. So this is the resultant equation of motion. Okay, now when two simple harmonic motions traveling in the perpendicular direction superimpose, then this is the final equation of simple harmonic motion, resultant simple harmonic motion. Okay, I tell you why I have named this equation as the final equation, because in one equation I have substituted the value of other. For example, in this here I have substituted the value from equation 1 in equation 2 to get out this final expression. Therefore, it's kind of a superposition. In other cases, we are literally doing x1 plus x2, but we are also doing the same thing but in a different manner. Okay, so we can say this is the resultant equation when two simple harmonic motion in perpendicular direction, they just superimpose. Resultant equation when two SHM of same frequency in perpendicular direction superimpose. Okay, so we will get this kind of expression. Okay, so from this equation, in the next part of the video, I will try to get some special condition, like putting the values of phi, the phase difference, and equating the amplitude of A1 and A2. We will examine what type of equation or what type of superimposed wave we will get in the next part of the video. So you have to just remember this final expression in order to derive those special conditions. Okay, that I will do in the next part of the video.